Welcome, everyone. I have the pleasure of introducing our speaker today, who's Nuri Halperin. He's the owner and principal consultant of Plus N Consulting. Nuri is a software architect, speaker, and author. He helps companies develop scalable systems, websites, and business applications. He's been turning projects into success stories for a variety of clients for over 2 decades. Nuri is also an author of several pluralinsights.com courses. He is also a Microsoft MVP alum, a MongoDB master, and a recipient of MongoDB's William Zola Award for Community Excellence. He enjoys tinkering on Arduinos, 3D printing, and mentoring youth robotics teams. Everyone, please give a warm welcome to our speaker, Nuri.
Thank you, everyone. I'll be trying to keep this session interactive. There's a lot of folks in the room, so if you have questions in the back, raise a hand. There's a mic, and we can get a mic to you and answer questions. This session is about common query patterns in MQL, MQL being the Mongo query language, distinct from SQL, which is something that begins with S, query language. And we're going to talk about patterns here. The agenda is going to include kind of a little talk about what humans and patterns and why it's important to make that distinction of patterns. But we're going to concentrate heavily about MQL and major operators in MQL, how they are arranged and stuff like that, and get some hands-on practice. So it does include labs, and when we get to the point, I'll point you to where and how we set this up. And we're going to also talk, time permitting, about query performance considerations when you're building your queries. So why patterns? Well, it turns out as humans, we can't do without them. At my age, it's a little harder to see, everybody very sharply in this room. But there's this kind of squintgram. If you just kind of squint at it, I can kind of tell there's clumps of people. My brain already makes groupings of people, maybe those with the dark shirts and yellow highlight, string kind of pop out, and my brain already tries to put them in groups. My brain already tries to arrange things. And this is no accident by nature. This helps us do things. For example, if I flash this pattern in front of you, you automatically know what the next slide is going to be, right? What's the next move? Bottom right. And it turns out that if somebody said bottom right 0 or bottom right X, it still works out. But we can see the pattern, right? We recognize a pattern, brings us to an action. We automatically know what to do next. So what if I could apply the same kind of thinking to querying? I'm faced with my data in my database, and I know I want to create a query to extract some information. And if I could harness this pattern-making ability of my brain to automatically construct the next step, then I save myself time. And if I do it again and again, I also build on my past successes, and I reduce the error rate because I can recognize a pattern, apply an automatically well-known, well-trodden solution for a common problem. So that's what this is about. It starts with observing something, looking at a problem, recognizing a pattern, letting that kick in, and then performing a reaction. What's my reaction? I'm going to construct a query. So, okay, that's all philosophy. Let's land it. For Mongo, it's going to roughly divide into 2 areas. The first area is the document structure. I'll want to recognize patterns in document structures. As a side, we have other sessions in, I don't know exactly what the schedule, but there are sessions about document structure and schema design for MongoDB. So if you're interested in learning more and digging deep about how to structure your data, I would recommend going to those sessions or seeing my course on Pluralsight on the subject or Mongo University on that subject. And then the other side is the reaction. What do I do? And it all boils down to arranging a pipeline sequence. So we will talk a little bit about pipeline sequence patterns to match those observations of the document structure pattern. Jump right into the document structure patterns. The first pattern is what I call the flat. The flat is characterized by fields in the document that contain scalar values essentially. Why essentially? They could be nested subdocuments. Those are still kind of flat. And if we squint at it and we just want to say, as a pattern, what am I going to look for? You're going to look for something that looks like this. I don't care what the field name is. I don't care if it's an integer or a string or a date. It's all just a scalar value. So you can kind of mentally align that pattern to say it's a row of colons top to down with nothing really to the right of them. The second pattern, a set. And in a set, what I have is a document that contains at least one field. And in that field, there's a bunch of elements. I'm familiar with the word sequence, so I won't say a sequence of elements. I would say a bunch of elements because it could be treated in two different ways. In Mongo, arrays can be treated as sequential, where the order of the elements has meaning. And it can also be in unordered things in the notion of a set. So when you write, you can say add to set, which will ensure there's uniqueness within these elements. So you can treat arrays in Mongo in two different mindsets. One is sequence, one is a simple set, an unordered set. And those operators make a difference in writing. They could make a difference when you're reading as well, namely that you want to pick a particular location within it. So queries to match will have to address that. The blurrogram for a set, the pattern recognition, forget everything else, just focus in and you'll see the square brackets. There's a colon square bracket, it's a set. No square bracket, it's a flat. And finally, the third major pattern is the nest. The nest is a set of a set. The nest has within the top level fields a more complicated subdocument of sorts or an array. And within it, elements are complex by themselves. They have multiple fields, or they can contain arrays underneath it. And it so happens that with MQL, we cannot really process a nested sub-element of a sub-element in many of the aggregation number crunching. We'll have to kind of unwind it in order to do things with it. But I'm getting ahead of myself. Because now that we've seen some patterns in the source, we see those fields. Now we need to kick in. What do we match up to it? So those will be the patterns. Sorry, this is a blurrogram for the nest. You can see not a single bracket, but a second bracket inside. There are variations of it where you see number one, you have an overall containing array, and then elements within the array with their squiggly brace, and then with them, there could be more arrays inside, or there could be even further nested squiggly braces with more fields. All of those are variations of nests. But the point is that there's not one level of indirection, there's a little more. To make use of any of this, we want to now go to the reaction side. What kind of patterns can we see in constructing the pipelines? But in order to get there, we need to have a notion of what we want to see at the end of the day. The boss came in, they said, I want sales by month, ordered by top to bottom region of sales. Or I want to know for each customer what the average number of items in their carts is, or things of that nature. So we do need context, because the overall pipeline pattern sequence will be affected by what I want to see. And this is not something that is constant, although the scenarios I mentioned are fairly common, I suspect, right? We've seen them all before. You will find a large variety, and if we try to do the Cartesian product of all use cases possible and all possible ways of putting 32 odd some pipeline operators in the query language, you'll get a very, very large matrix. So for our exercises today, we'll kind of narrow it down and drive it by a few kind of common scenarios. But there is actually an archetype for the pipeline queries, and roughly it's gather, assemble, and present. Why not use ETL, Nuri? Because there is no L at the end. And why not use ELT? Because we're not talking about operational patterns, we're talking about patterns in querying. So we want to gather the data, we want to assemble it in some way, and we want to present it finally. And this archetype is recursive, meaning that within each major item here, we could see that we construct a few operators and in the same thing, like, oh, for this pipeline stage, I'm within it going to have a little pipeline of just gather, assemble, and present will be for the next stage. So this is really a single pattern, a single Uber pattern saying, look at what you got, crunch some numbers, and then arrange it for the next consumer. That is the query pattern, the Uber query pattern. Let's break it down a little more. We're going to go into the gather stage. What do we do in gather? Well, largely we find documents. We look to things like doing filtering, putting documents in order for the next stage to have things in a certain order. You know, if I want to say select top one kind of thing, I need to have the notion of top. I need to arrange them in order to pick the first one or the last one or whatever. Typically one collection, or historically one collection. Nowadays we have $lookup and recursive lookup, so sometimes it's multiple collections. But finding documents is about identifying of all of my data, which ones do I really care about, right? The other role that this gather stage does is to liberate data. Sometimes our data on disk, our document model, has been designed by someone intentfully to hold data in a certain way, but it is not the best way for my querying. So this is a bit of preparation, a bit of gathering information from fields that were embedded or embedded incorrectly in a document. Maybe somebody stored dates as strings. Maybe somebody had a bunch of fields strewn around that should act as a single field. So those I also considered in the gather stage because they are done before I do the real number crunching. So it's just kind of picking information out of my data, picking fields and deciding what values are important for me. So I'm picking which documents and I'm picking which fields in documents. Gather. Next is the real work. The real work is going to be done here in the assemble stage. And in the assemble, all the things I gather, I need to do some math on. And if you're telling me, hey, Nuri, you know, all I need to do is just collect the original documents and I don't need to compute anything, I would say, that's good. You can maybe even use find for it, right? Assemble really is about cross-document computations. It's something that was not available without the aggregation framework. We could do it with find. Historically, we could do it with MapReduce, which is tricky at best. So with the aggregation framework, this, and the major workhorse here, I'll tell you, is the $group operator. Think of this stage of the pipeline, and in this pattern, this is where the number crunching happens. It computes data across documents that entered into the pipeline. Can it do other things? Sure. Are there specialized operators? Yes, but largely speaking, this is about the group operator. The group pipeline stage, I should say. Finally, after I crunched all of this, I have to make it usable for humans. Now, humans, it could mean a machine, but I need to take all of the information that I assembled, I computed across, and I need to either throw it back at the application that requested it, or persist it into some document somewhere, or into a collection, or nowadays you can even pour it into S3 Parquet files. So I need to take it, wrap it up, do whatever I need to make it beautiful, or to store it for posterity, or arrange it for whoever consumes it. At that point, I'm already post-processing. I'm already after the assembly, after the big number crunching. So what I'm going to do here is light touches, but they can have an impact. And we'll talk a little more about performance later. But this is where you get to say, I don't need to send all results back to the user. I just need the top 3 salespeople, or I just need the most popular items ordered today, or things like that. And it can have an impact on performance, because here I could say things like reduce the amount of data that returns, either by cropping out fields that are unnecessary or how many I return. And by doing that, I reduce the overall load on the network, and maybe keep cursors open for shorter amounts of time if I send less data, things like that. After talking this through once, somebody from Mongo gave me the great tip to kind of familiarize and show the usual suspects. Because all I said now, for folks who are familiar with the aggregation pipeline, it may make a lot of sense, but for others, maybe a little less. So there are frequently used stages. $match is a filter. It's something we'll typically see on the first stage, which is gather, right? $group for the middle stage, and the final stage like sort, or putting things in order, and project, which arranges fields and crops them out, or invents new fields, or renames things, or does like small amounts of math. And then some more operators, unwind for arrays, lookup, graph lookup, specialized for doing specialized join type operations. $out to persist your information back into Mongo instead of returning it to user. Merge, the more modern, and I would say the one you should use instead of $out. And add fields to, again, do fit and finish type stuff like project. So these are very common. And then there's some that are maybe less common, and I'm not going to read the slides to you. We can talk about each one of the 32 pipeline operators for a long time, and that's not the purpose today. But there's things like bucket, which is great for search type applications. Things like $count, facet. Facet and bucket have some relationships. Redact, sample for data sciences to get statistical sampling from a collection, things like that. Skip and limit pairs are used for paging. So that's another kind of fit and finish, another thing for the end. I just wanted to throw this in front of you just to, for those of us who are more beginners, just to to kind of maybe make a mental note that these are the things we're going to do. So next I'm going to move into the first one of 6 katas. I'm going to explain a little bit about the operators, and we're going to jump into labs. Before I do that, I want a chance to maybe give you guys a chance to maybe ask questions or anything about so far about kind of pipelines, about anything until now.
Does anyone have any questions? I'll come on over to you.
Can you re-explain that why we are not using the term ELT or ETL?
Why are we not using the
term ELT or ETL? Instead of that, we are using gather, assemble, and present.
Yeah, so the question is, why aren't we using ELT or ETL, traditional database engineer, DBA kind of machineries? And that's because this is a query language within Mongo. This is the aggregation pipeline. And we run it inside Mongo, inside the engine. So we send a command to Mongo to process data that is within Mongo. And when we typically talk about ETL and ELT, we talk about external tools that then consume external data sources to bring into your traditionally relational database. Okay.
Other questions?
One in the back there.
Oh, I'll come to you. Here, I'll hold the mic.
Hey, is it possible to store the result of an aggregation into a variable, like a dynamic result, instead of outing it to a collection?
So the question is, can we store the result into a variable rather than into a collection? The answer is kind of yes, of course. So Mongo is a remote server to you, namely that you send it a command to run a query, and you send that command from a driver, from a shell, from an application. So we realize that always will be kind of coming back to you as a variable by default. Only if you put the last stage of your aggregation pipeline with a $out or a $merge will it go into storage. Otherwise, it will return a cursor to the application. So the application will always get a cursor back. A corollary question, I'm not sure if that's what you asked, is there a way for me in the pipeline to kind of keep a running tally variable within the aggregation pipeline? And there's very limited support for that for very specific use cases, putting kind of global context, but not really.
I was interested into knowing if there's a way to use the variable into a further aggregation, different collection maybe. Just like using out and merge in a further aggregation, instead of an actual collection, can we replace this collection for a variable?
So if I'm understanding the question correctly, and I'm not sure I am, you're asking whether instead of sending a fixed name of a collection, I will use a variable for the name of a collection. And the way I would think of it myself is always yes, because you are in charge of composing the query. The query doesn't live on the server. It's a command that your client generates. So when you want, you can create a query template and just give it a collection name and send it with a command with that merged in collection. As far as Mongo is concerned, you don't give it variables. It has no concept of how to fill that. You give it completed text commands. So if you wanted to make a query that changes in your application, one day query the Sunday and one query the Monday collection and the Thursday collection, you will be composing those queries on the client and just sending them. And Mongo will process them as they are. And as far as cache hits or things like that, you're thinking about templates and SQL and this. Mongo does cache what Mongo caches at the moment, and if it hits a cache, it'll enjoy it, and if not, it will process it anyway.
I'm going to come to the guy in the front. I'll hold the mic for you. I'll hold it.
Yeah. Can we store a given pipeline, like once we have the sequence in the MongoDB, like later on we can just refer this pipeline and you get the result?
Can you store the pipeline itself? Yeah. Kinda, because Mongo has the notion of a view.
Yeah.
And if you define a view, the view is really just a pipeline prefix. It's a pipeline you create. A view is an aggregation pipeline expression that gets stored. And then with the next, when you want to query that view, you can give it a pipeline that will just append together. So in that sense, yes, you can store a view and then query the view.
Okay.
And then it effectively is using an underlying mechanism of taking a pipeline and storing it on the server and giving it a name. Yeah.
Okay. Yeah.
A view is a named stored pipeline. Yeah.
I have a question about, you mentioned that in the out and merge, you can feed it back into an S3, for example. Are we able to use connectors inside MongoDB?
To my knowledge, no, but I would say go ask the experts on level 3 with the White Coat Labs on how that S3 output works. I'm not terribly familiar with it.
I might actually have the answer for you. You can use Query Federation, which is a new feature we just announced, to send your end result to S3. It's through our Data Lake product.
Okay, great. And just a quick follow-up. So you can either return the results of your pipeline or directly store it in a new collection within your cluster, correct?
In a new collection and with merge into an existing collection in a smart way that lets you merge it, ooh, nice name, instead of overwriting values or only appending, which out was very violent this way, merge lets you in a more nuanced way accumulate running tallies into an existing or a new collection and into an existing or new document. So merge is the one to use, out is the one that used to be there, use merge.
I'm going to come over to you. Just give me a sec.
So we'll take one more question, and then we'll get into a little more syntax and some of the labs and the exercises.
In the product that I work on, we use a lot of complex queries that we have a lot of joins, but I understand how to get around that. But we also use a lot of unpivots and pivots. What would you suggest is the best way to kind of get around that but still get the same aggregation or the same results?
I think I lost you at the same stage of the question.
Yeah, we do a lot of business calculations for different key performance indicators. And in our queries, we have unpivots and pivots on different tables and fields in those. And we're having trouble trying to translate that same process into a Mongo aggregation. So I was curious what your take would be or suggestion to try to get around that.
Yeah. So the consultant in me wants to say it depends, and let's look at your particular scenario. But for the room and for the opening up of mind and the possibilities, I would say that the equivalent for pivot unpivot is $unwind and $group by with $add to set or $push. So those two perform the mechanical closest equivalent to pivot and unpivot.
Okay. And then
However, I would caution that those are potentially heavy processings and that proper modeling of your data might get you way better mileage.
Yeah.
So for those of us beginning, we're talking here about structuring data. In this talk, we're talking about, I already have the data, but I'm inviting the question, is my data stored correctly, so that I can perform those queries? And that's a question that needs digging. Yeah.
That's pretty much the conclusion I kind of came to as well. I was just curious your take.
Great. We're in agreement. Awesome. Okay, so switching things a bit. Hopefully we've seen kind of the patterns. We remember there's like flat stuff, there's like nested stuff, and there's like, ooh, very nested stuff, right? That's on the source. And then all of our pipelines are kind of gonna look like, oh, we gather some stuff, then we crunch some numbers, and then we put fit and finish, and then we return them to the user or just pour them into a collection. So in the next section here, I'm going to show specific syntax to arrive and to leverage specific pipeline operators so that you can compose a query. Before we jump in, I think not everyone has laptops, and I'm not sure everybody is intending to do the labs. So I'm going to walk through a few of the examples, and then there's labs, and I'll give you the URL and everything that you can do even later. So if you're not interested or not capable of performing the lab right now with this tutorial session, that's okay. And then after the labs, I have a little more discussion on maybe performance insights and things like that around constructing queries. So what I might do is kind of jump back and forth, do a little of this, and then jump to the lecture type, and then let folks work on labs on their own. So just room temperature, how many folks are capable to actually do labs right now? Oh, a lot. Okay, great. So we'll just go with that. Sounds great. So the first exercise, I call it pass or not. A little Gandalf here. This is really about which pattern, which part of the pipeline. Gather, right? So this is about gather. We are talking about, I have some data. Do I need to load it or not? And the operators there largely are match, sometimes sort, skip, and limit. The way match works, match is a filter. So $match in an aggregation pipeline will typically be one of the first elements. It can appear multiple times, but really at the left of most all your aggregation pipelines, you should see a $match. $match takes the same expression as find does. So it just takes a field name, in our case here, city, and a value, Kent. So it's kind of query by example. It says, I want to have documents that have a field city with a value of Kent. If I have a document with no field name city, it will not be returned. If I have a value of city that says New York, it will not be returned. So it doesn't really care if the field doesn't exist or if the field exists but with a different value. It must match in order to pass. Match, $match, it must match. Okay, that's easy. Second is sort, and sort takes a field name and a direction. So we can say, I want the documents. Any document that enters the sort stage will be returned, just maybe not in the same order they entered. I'm making an assumption that all of us are familiar with pipeline and the notion of pipeline, but let me just state this, that in a pipeline, each pipeline stage feeds the next one. The first one sees the document in a collection, but anything subsequently in the pipeline will only see documents that came from the previous stage. So when we're looking at match, match really marshals what's going to enter into the next stage. What's going to enter? Sort marshals in which order is it going to enter the next stage, but does not at all remove any documents or suppress anything. It's just a pass-through in that sense, in a pipeline sense. And then skip is kind of an odd marshaller that says, I don't care what value you have. You're the first three, I'm ignoring you. And then, well, skip one is on screen. So you're the first one, I'm ignoring you, and then the rest of them enter unharmed. And limit does the opposite. Limit says, you 10 come in, and after you, nobody else, club is closed. Okay? So that's the structure. For those of us beginning, the syntax reads literally with, within a shell or something. db.foo, foo would be the collection name. And then the keyword aggregate, which is the aggregate command, open parentheses, put a square bracket, and the things in the array are a sequence of pipeline operators. So $match, $sort, $skip, $limit, they're all pipeline operators. And they're all in that arena that I call gather. All right? So this is where you can grab the labs. It might be easier to just go to GitHub, nuri-h, and then in the repos, there's only one repo called MongoDB-MQL-patterns. Hopefully the Wi-Fi works for us. I'll keep on this slide for a minute. Let you type or grab this. And the way these labs are arranged is that there are folders for each lab. And in the lab, there's a little document that says README, and it will have the lab content. It will have the instructions. And then there's also a solution document next to it, which you obviously would not look at because it's way more fun to try to solve on our own. But in case you want some reference to a way to solve it, then there's a solution document. All of these labs, you don't have to have Mongo installed. You don't have to have an Atlas account. We're going to do it all through a thing called Mongo Playground, which is an awesome online tool where you can play around with data sets and use real Mongo syntax in the browser without provisioning anything, without anything. So that should be easy. Did everybody get a chance to grab the URL? Okay, I can bring it back if you're didn't get a chance to do that. Sorry. I'm going to switch. I'm going to switch here to, is the font large enough for those in the back? Can you read it? More or less? How about now? Yes? Awesome. This is Mongo Playground, and the URLs for each one are attached to each lab, so that's easy. I'm just going to talk a little bit about the operators, just to kind of give you a taste for how it works. In the first one, we want to use the match operator, and we have a collection named peeps, short for people, for boomers like me. Yo, peeps. So peeps is a collection of people. Each person, each peep has an ID that has something that looks like a first name and a city they live in. So I can do something in order to say, look for people named Bob. I would type in what? $match. And lo and behold, it already, wasn't there a beautify button, Control K, Control something? Sorry? KD or KE? Nope. Oh, okay. I do this, And, oh, it didn't, yeah. So anyway, so I have to say, look for a person whose name is Dan, and control, and I'll run it. It expected something. It's disappointed at me. Let's get back to safety here. I need a squiggly brace. Yes, thank you. Dollar match. And then I need a field, let's say ID. And a name, Dan. And pray to the gods of close braces. And here we go, we have Dan. So query by example will take a field and exact match it. I can also say, I want all people whose name begins with the letter D or above. By, instead of saying that the ID is Dan, I could add an operator here saying $GT. So Danny, Daniel, Dan, Dan Xavier, all of those should come back. You notice that Jan begins with a J, definitely above Dan. Kim with a K, great. But Bob, which starts with a B, did not get returned. Here's my data set there on the left. I don't have to actually do it on the frill string. I can just say anybody whose name begins with something above D. I know the alphabet fairly well, A, B, C, D, E, so E is the next letter. If I wanted to include D, I could say GTE. And GTE will say greater than equal. Similarly, there's LTE, LT, and $not. So everybody except Dan is $not. It's a great question. The question was, does it support regular expression? And I could say something like, where ID, I don't know if it's extended JSON here, but I could say starts with D and then some, letters and stuff like that. I could do that. I stay away from using regular expressions because they're costly, and sometimes they can use indexes, but it's very quick. It's very quick to mess them up and make them non-efficient. So I try to avoid them as much as I can. I'm sorry, I can't hear you.
There's also a Regex operator.
A regex, yes, regular expression, yes.
There's one just like not in GT that you said. You could just say regex there.
Right, and there's a shorthand syntax where you just give the slashes.
Like you said.
My point, though, is let's pretend it didn't exist. Some things in Mongo, myself, I don't work for Mongo, and I can say it. Some things in Mongo I don't quite love. And one of these things is it's rich, right? It lets you do things maybe are difficult to do otherwise, but it's not the most optimal way to do things. So I try to find those things and optimize out by avoiding using the pitfall kind of operators. Yeah. Comment.
Okay. I just wanted to mention that Atlas Search has a regex operator and works much better than with the Lucene indexes rather than the traditional one.
Right. So our session here is about Mongo, the engine, which is what's running on Atlas, but other offerings such as the Mongo Search and other of the ecosystem might do a much better job. And you might not need regex because once you have a full text index, you can do fuzzy matches and it's way better. Okay, so with this, this is actually the link for the first kata. So I'll bring up the kata. Everybody had a chance to look at the GitHub, and we'll take a few minutes just to let you kind of try the syntax on the match and maybe sort skip, and then we'll move on, okay? Can I do what kind of matches? So the question I think is, does match have to have exactly one field?
Yeah.
Or can it have, say, ID of Kim and city of
Yeah.
Kent? And the answer is yes.
Okay. Thank you.
But can it do multiple fields or somebody whose name is Dan or the city is Kent? And the answer is yeah. You can say $or. Now I'm not doing it right. I know I'm not. Live demos. Yeah, so what I have to do is I have to put this $or before all of this stuff. Right. Some like that, right? So you can do an and, you can do an or. Yes. So the way we do this exercise, we open the README, and the README says, open that playground that I just showed you. Look at the data set, peeps. Okay. Dear diary, I stared at this one. Great. Then what document pattern does the document exhibit? Flat, right? We have no square brackets here, nothing on the blurrogram that tells us it's anything complicated. All values have, all fields have scalar values. And then create an MQL pattern to return everything for people who live in Jackson. So I look here, okay, there's Jackson, and I want to return everything, meaning I don't want to mess around with any fields in the document. All I want to say is filter, right? So what do I got to do? Thank you. Capital J Jackson. It's good. Match, for those of you who thought of asking, is case sensitive. But, and we can't do it in Playground, I don't think, but on real Mongo, you can set collation for an index and for a collection. So if you want case insensitive matches, you can set that up so that the match will become case insensitive and accent insensitive, if I want. Okay, so number 4, MQL pattern, return everything for people who live in Jackson, got it. Return all documents in order by city name, ascending, then by a person's name, descending. So return all documents in order of something, which means all document means I'm not actually applying a match. My first operator would be $sort. And I want to say by city name first, ascending, and by person's name, descending. So I will say by city name, ascending. Sort is kind of funny this way. You give it a 1 to say I want order ascending, and -1 to say I want descending. So maybe with a thumb, it's a good memorization. Up is plus and negative is down. So up, sort up by city, ascending, and then by person's name, descending. So cities are Boulder with a B, Jackson with a J, and then Kent after H-I-J-K, yep, right order. And then within a sorting that I have Jackson and Dan, I have in Jackson, I have Jan and Dan. It's first Jan because it's descending. So J is higher and Dan is lower. So I see that result comes in the correct order. All right? So we're doing okay on time, but let's kind of push on to the next kata. The next one up is looking at bunching things up. What pipeline stage am I looking for? Assemble, that's right. So here, when we already identified which documents, which fields we want to deal with. Now we get to crunch the numbers. So this is the group operator. And the group operator is the major workhorse of aggregation pipeline. It takes the form of the word $group, followed by a squiggly brace, followed by the underscore ID. Nuri, you told me all of these rules. What do you mean? I can't do whatever I want? Yeah, we'll get to that. But first, there's rules. It must have a underscore ID. Because for grouping, I need to say what I want to group by. I need to say what is the thing I'm going to label each of the groups. And that is the underscore ID, because in Mongo, every document has an ID. So group must have a underscore ID. The name of that field is exactly as is. You don't like it? Well, guess what? You get a chance later to use project or something in the fit and finish stage. But for now, this must be just like that. Second peculiarity about group is that that ID, that value that I say quote all, is just a constant, right? So the value I give it can be either some constant that I provide at query time, but in this case, I'll have only one group, the group named all. I could call it something else. I could call it the group named Nuri or the group MDB22. Doesn't matter, but it's a constant. Most of the time, I won't use a constant. And on the second example on the left there, you see that I'm using the $subject as the grouping construct. And here on this slide, I'm saying I want to group by $name. So here it's $subject, here it's $name. What that means is I want Mongo to pick the field value of the field named name and use it as a grouping. So if I did it by city, Jackson, right, we'll have two people. So I would say $city, right? So when you see dollar to the left of a colon, like group is to the left of a colon, that dollar means I'm a name of a pipeline operator. When you see dollar to the right of a colon, like $name here, on the lower line, that means I want the value of field. So that's important because how many times did I type name and I'm like, why isn't it grouping? And it went and killed my cluster and scanning a lot of documents and like, forgot the $sign. So don't forget the $sign. Okay? So this is for grouping. Group by what? Something. What's that something? Either a constant or value of field. Constant, just quote it. Value of field, put a $sign in front of it. Does it have to be a string? No, it could be a number, it could be a date, it could be anything. You can group by any value, but you have to say what it is. After you did this business with ID, then comes the aggregation operators. Sum, average, min, max, push into an array, add to set. All of those are ways to bunch things up. Some of them mathematical, some of them set theory, but they're all operators that are specific to the $group pipeline. As it turns out, Mongo doesn't have a count operator at this. There is a $count pipeline operator, but it doesn't do what you think it does. So the way to count how many items in a group, let's say you want to do how many people live in each city, you do a sum of one. Sum of one means add up a one for each one you see. So there's no syntactic sugar for that today. That's how you count. On the bottom, we see using the $average, and that intuitively behaves how math behaves. So it does the average of scores. There's stdev and stdevp, and avg is mean.
No.
Are you talking about median or mean?
Median, sorry, yes.
I don't know. Any Mongo folks here? Is there a dollar median operator? Yes. For ag? Yes, there is. I should check that.
I thought that they added something in 5.1 regarding the $count in groups. I think that might change.
Yeah, it's not a group operator. It's a major pipeline operator.
No,
it's more like bucketing.
In 5.1. I'll need to search it.
Okay.
Well,
Yeah, so there is a
median?
$count operator, but it is not used inside a $group to count items, as far as I know. You can do things like $length of an array, but not an aggregation. Okay. Yes, sir. Yes. So the question is, can you group by multiple values? And the answer is yes. Just as we saw that you can say match on multiple fields, inside the ID, I can, after ID, I put a squiggly brace and put field A colon value A, field B colon value B. So yes. If you want to see the shape of this, it would be like, returning my mouse to me here. If I were here and I said, this is a second kata here, group, and every group must have an ID, and I'll start with all, and then I'll say n is the $sum of 1. So here in the scores original collection, I had 6 documents. Trust me, I counted. And then I said group by all of them. So it just had one group on the out and counted each one. And then if I wanted to say group by subject and count how many per subject, I will say $subject. So you see each document has a subject to it, and I can extract that. And here you see value of field. And then if I wanted to say group by the year or the month, I would have to do something to look into this date. This is in fact stored as BSON. It's a natural date. It's not a string. So there's an operator, and I can say I want by subject subject, and then let's say mo would be the value of $month with extract that from the field DT.
And Nuri, I've checked, and like in 5.0, we've changed that you can use $count inside a dollar group. That it's exactly the same as $sum1 because we know people were complaining about it.
Okay, awesome. So good news, you heard the announcement a year and a half ago at 5.0 it was added. Awesome. Missing closing bracket. Comma here. Thank you. So to the gentleman with a question of, can I have an ID that is compound? The answer is yes, and you can have a year, comma, month, or whatever grouping you want, obviously. Yeah. Okay. All right, so we're running kind of deep into the minutia of particular operators. So for the interest of time, what I'd like to do now is move on to discuss a little about discussion, and then open up to questions again. And all of you here, if you haven't gotten a chance to get the GitHub repo and want to practice on your own, catch me later. I'll flash it at the end of the talk too, and we'll just continue talking because this is an interactive group and great questions. I'd like to address them all. So we're here. The very important pipeline operator, unwind. We talked a little about pivoting, unpivoting. Whenever you see a nest, you will invariably use unwind. The way unwind works is it looks at array source elements and emits for each element of the array the whole document with just this one item from it. So if I had a document with an array of 3 items and I pass it through unwind, it will make the whole document with item 1, the whole document with document 2, the whole document with document 3. In came 1 document, out of unwind came 3. As you can imagine, has some memory and resource implications. But as you can imagine, very necessary stuff in a document-oriented world. So that's the way unwind works. And there's nuances, like if the array was in order and the items were in order, you can actually add an index and say, ooh, this document and element pair are the first or the second or the nth element, or you can ignore the order if it doesn't matter. Not going to dig in deep. Just going to skim through this one. In terms of isolating, when I want to take a particular piece of a field, sometimes what I will have is a document that contains a customer, and the customer has an address field, and in the address there's city, state, zip, country, stuff like that. So if I want to address items within it, I can just use the dot notation. And because I can use dot notation, Nuri's claim is that this document, even though it was seemingly nested or a sub-document, it's actually flat. Because I don't have to unwind it. I don't have to do anything special with operators. I can just give the field path to it. So as long as there's just a field path with a scalar, I call it flat. In terms of shaping things finally before returning them to the customer, the main workhorse there is project. The project operator lets you do things like rename fields, do light math computations, let's say quantity times price or something like that. You can do simple math because it's only within one document, right? If it's cross-document computations, I have to use group by. But for simple math, I can use project. So it lets me rename fields, suppress fields, meaning not emit them, or invent new fields, taking some values and creating a new field. So that's project. That is really the fit and finish. And after project, the document looks exactly like you want. There's no real use putting project anywhere but the end. Because why would I need to project in the middle? I gathered stuff, well, it's in its original format. I crunched numbers, what do I care what the field is named? Only really in the fit and finish will I typically find project. Then I have, as my last kind of idea, is pulling it all together. Once I look at a whole pipeline, I will rarely find just a single element, a single operator like match or stuff. It will be big, right? I have a lot of data. I have a lot of reporting needs. There will be complexity. And the pipeline operator is made for that. That is why it is a pipeline. It is made to take stage by stage by stage by stage. So in our example here, we see that we start with a match, very typical. Then we are using an unwind. So I know that my document maybe had a nest in it. I'm unwinding colors. Then I'm doing group, then sort, then limit. So final quiz, match. What pattern, what pipeline pattern does it belong in? Gather. Anybody think of anything else? No. Unwind. Unwind takes an array, breaks it apart. Assemble. Any other opinions? I actually classified unwind as a gather stage. And the reason I classify it there would be that it doesn't do cross documents. It produces multiple documents, but it just takes some fields and unwinds them and liberates a few pieces. It doesn't need cross-document thinking. So if it didn't need that, we're still just assembling stuff for crunching later. Does it matter? Doesn't. All I'm talking about, these patterns, are just concepts. They're here to guide us, to help us, to develop intuition. It doesn't matter if you classify it this way or that way. As long as you make a pipeline that serves your purpose, you've won. It's fine. Group, what stage is it? Assemble for sure. Sort. So sort looks across documents. It's true that it has to see all documents before it can decide which one is first and which one is last. However, it doesn't crunch any information. Whatever comes in, comes out. So I don't consider it a assemble stage. I consider it fit and finish. Just before presentation, I want to do something, like sort it, and limit also in the present. So I would classify sort and limit in the present category. I talked a little bit about those pipeline stages, and I said, well, let's think about performance a bit. What can I do, and where can I do it? So I have my major pipeline stages, and I picked the right operators to do whatever the bot said, so okay, fine. But how can I eke more performance out of it or construct it in a way that is more ready for performing well? So we have these 3 stages, and what can I do at each stage? In the gather, I would want to reduce the I/O. Gather, unlike everything to the right of gather, is going to look at original collections. Original collections are stored on disk. Disk is the slowest part of the computer, other than the human. Well, that's not part of the computer yet. So gather is the first stage. It sees collections. How do I make access to collection data faster? Indexes. So thank you for that. Indexes is how I make it faster. In gather, and especially match, also sort, by the way, can look at indexes on the collection because they're just documents on disk. So in gather, I really want to consider collections, indexes, and I want to make sure I'm using a match to limit the amount of data coming in. What's the opposite of it? The opposite of it is if I didn't have a match, it will do a full collection scan. And that's just a lot of I/O. I don't care how big your machine is. If you have a lot of data, that will hurt your performance. So we want to really use $match and $sort at the early stages as much as possible because they can take care of take advantage of indexes. Those same operators lose that ability when they're further to the right. If there was any transformation happening before that, projects and group bys and things like that, now, later in the pipeline, they do not have any relationship to the original document on disk, or it's been obfuscated, so using indexes is off the table. So that's what I can do in gather. Next, in the assemble stage. At the assemble stage, I've already gathered, so all of that magic and using indexes was done. Those bullets were spent, so to speak. So what can I do in assemble? Reduce work. Don't do things that are unnecessary. Don't do things that are just because. Generate as little information as you can still to fulfill the workload. That means don't generate huge field names. That means don't accumulate every document by saying, oh, I'll count them, but I'll also just collect each one and I'll do a push into an array and keep the list of all cities I just counted. Like, dude, do you want to know the names of them? Okay, well, there's a workload like that, fine. But if all you wanted to do is count, don't put extra debugging information or extra stuff that will just blow up memory. This is an area where things ramp up memory, and in group, if the pipeline exceeds 100 meg in usage, Mongo will shut you down. And then you can tell the aggregation pipeline, hey, I want to use disk swapping. I want to allow paging to disks in order to compute big data sets, but it will be slower. So whatever you can do to kind of narrow down your workload and to ensure that you're not doing extra work, that's what you can do there. Finally, in the present, what kind of optimizations or what kind of considerations I have there. In present, I really want to be thinking about, well, how much of this data does the client really need? Huh? So here is somewhere where I can put a limit or a skip that instead of shipping whole data sets to my client, I ship a slice of all documents in the hopes they don't need more. Or I get to reduce junk documents that they wouldn't need anyway, or maybe remove fields that were used for computation in the assemble stage, but now I want to get rid of them because they're not for presentation, that's just for intermediary storage. So those are the kind of things I want to do in the present area. With the addition of the $merge, I have another more sophisticated opportunity, which is running tallies, running sums. So where previously, in order to compute month to date, I would have to consume all of the month and, you know, on the 15th and on the 16th, and you can imagine I'm accumulating data, but I'm recomputing everything from the beginning of a month. But with merge, I can do things like accumulate a day at a time and just append it to the monthly tally. So I'm only considering a slice of one day and adding it to the tally. So if the math works out okay and you can, you know, you're counting or you're adding, it's additive, then you can do that. Okay? So we are kind of short on time, but I'm happy to answer any more questions.
Yeah, we have a minute left of this session, so I would encourage everyone to stay after if they'd like. We do have to clear out the room, so if you would mind, Nuri, maybe you can take questions outside. I'm not asking everyone to get up right now. I'm going to take a couple questions, and then I'm going to ask everyone to file up.
For the merges, are they also able to utilize indexes and things like that to boost performance? We've had some issues with slow merges in the past.
For the internal implementation, I would recommend talking to a Mongo person, okay. Or maybe the labs. But I think they are able to take advantage of target collection indexes.
Okay.
Source collections, the indexes are gone by that time. There's nothing to be smart about. But yes, it is able to merge. What you have to be careful is not creating hotspotting where you're doing parallel merges into the same document. You might run into issues. That should not happen. That is not, it's not the way of the stream, right? You want to batch stream in things. You don't want to attack the same document.
Yeah. Okay.
And if you did, those hotspots might be parallelizable, where you can create intermediaries and then aggregate those and just create multiple multiple steps in your journey rather than thinking of one operator to root it all. Thank you very much. Enjoy the rest of the show.
Thank you, everyone.